Hello everyone, this is INE Foundation Lab 3 and section 5.1 iBGP. Okay, let me explain BGP concept and I will come back and conclude this section. Okay, let's start by BGP port number. BGP uses TCP port number 179. This port is designated for establishing TCP connection between BGP routers to exchange routing and retrieving information across different ASs on the internet. Keep in mind that BGP uses TCP port numbers 179. Another BGP concept is BGP Update Source command. By default, BGP establishes the session using the IP address of the outgoing interface or closest to the neighbor interface. We can change this behavior by BGP Update Source command. In scenarios like redundancy, for redundancy in our network, it is better to use loopback interface as source instead of outgoing physical interface. We can change this outgoing physical interface to other interfaces like tunnel interface or loopback interface as source by BGP Update Source command. We can use BGP Update Source tunnel interface or loopback interface instead of physical interface. The default, if we don't specify update source, it will use our outgoing interface as source. Okay, in BGP there are two types of AS number formats. One is 2-byte AS number and the other one is 4-byte AS number. 2-byte AS number ranges from 1 to 65,535 and 5-byte AS number ranges from 1 to this number. Okay, there are two ways to represent these AS numbers. One is AS plain, the other one is AS dot. AS dot is new one, and AS plain is our default. AS plain represents both 2 bytes and 4-byte AS numbers as decimal values, like this one. In AS plain, both 2 and 4 bytes are represented as decimal values. In AS dot, 2-byte AS numbers are represented as decimal and 4-byte AS numbers are represented as dotted notation. This is 2-byte is represented as decimal and 4-byte AS number is represented as dotted decimal using dot notation value. This is decimal and this is dot notation. As I said before, the default notation is AS plain, which turns the 32-bit binary AS into a single decimal value. So like this one. And in the AS dot notation, a 4-byte AS number is represented as a 2-byte value separated by a dot or period. This is like this. These are each one has 2 byte and 2 byte, and separated by dot. This is AS dot, and it breaks down the 32-bit AS into a 260-bit section, separated by that. And the left side is represented as higher order, and the right side is represented as lower order 60-bit value. For example, AS number this in AS plain format becomes this one in AS dot, and AS number this in AS plain format becomes this number in AS dot notation. So these are, each one is 60-bit AS number. 60-bit section. This one is left side is higher order and right side is lower order. And to change this default AS default AS plane to AS dot, we can use this command BGP AS notation dot command on the BGP configuration. Okay, let's see the difference between iBGP and eBGP. Let's see the purposes. iBGP uses to propagate routes within the same autonomous system. It ensures that all routes within the AS have the same view of network topology. Okay, to conquer iBGP, both local AS and remote AS should be the same. And eBGP is used for propagating routes between different ASs. And it connects distinct networks such as those belonging to different internet service providers, ISPs. And to configure eBGP, local AS and remote AS should be different. And let's see the distribution between iBGP and eBGP. iBGP does not allow for route redistribution, but eBGP supports route redistribution. This is key thing to understand, that there is no route redistribution in iBGP. This is BGP Synchronization Rule, or iBGP rule. By default, iBGP does not propagate routes learned via other iBGP neighbors. In an iBGP route, routes learned from one iBGP peer are not automatically propagated to other iBGP peers. I will explain this now. Okay. What is BGP synchronization rule? Okay. When iBGP does not advertise route learned from iBGP neighbor A to iBGP neighbor C. Okay, let's see here. We have RTI-A. We have iBGP neighbor between RTI-A, RTI-B, and iBGP neighbor between RTI-B and RTI-C, and eBGP neighbor between RTI-B and transit router. Okay. Okay, if this transit router advertises route to RTI-B, then RTI-B will not advertise this route to iBGP. And it will not advertise this route. Excuse me, I miscopied this. Let me explain this. This is eBGP between this one. Okay. Okay, if transit router advertise this route to RTI-B, this is eBGP between RTI-B and transit, then RTI-B will advertise this route to another iBGP neighbors. It will advertise to RTI-A, and will advertise this route into another iBGP neighbor, because it distributes this route from eBGP. Transit advertise this eBGP neighbor between RTI-B and transit. If transit advertise the route to RTI-B, then RTI-B will advertise the route into RTI-A and RTI-C. This is normal behavior. And if we see, if RTI-A advertises to RTI-B, then RTI-B will advertise this route to transit. but will not advertise this route to another iBGP. This is how BGP synchronization rule will work. BGP will learn from one iBGP neighbor or not propagate to another iBGP neighbor. There is no iBGP to iBGP connectivity advertisement. There is no iBGP to iBGP advertisement. And let me see another one. And if RTRB receives route, if RTRC advertises route to RTRB, then it will not advertise this to RTRA. There is no iBGP to iBGP advertisement, but it will advertise to transit. This is how BGP synchronization rule will work. It's with from transit to ANC, with from ANC to transit, but will not between, there is no advertisement between A and C and C and A. There is one BGP command, BGP redistribute-internal. This command allows the redistribution of iBGP routes into IGPs, such as ISIS, OSPF, or eIGRP, not into other iBGP peers. This command is for redistribution of iBGPs into IGPs, not another iBGP. Keep in mind, this is important to understand this command. And for overcome this iBGP to iBGP issue, we can use route reflector or BGP computation. This is how BGP synchronization rule is working. There is no redistribution in iBGP. Okay, let's see topology view of iBGP and eBGP. iBGP requires a full mesh topology. It means all routers within the AS must be directly connected. But in eBGP does not require full mesh, and routers can be selectively connected. And this is another reason for full mesh connectivity, and for easy configuration, we can use route reflector or BGP computation. And loop prevention. iBGP uses BGP split horizon for loop prevention. This is BGP, as I explained before, this is BGP split horizon rule. This is iBGP will not advertise or propagate routes from iBGP to another iBGP or vice versa for preventing loop. And for prevention loop prevention, eBGP utilized AS path attributes. And unlike eBGP, iBGPs do not prepend the AS numbers to the AS path attributes. Keep in mind, iBGPs don't prepend the AS numbers. There is another feature of BGP, this is BGP synchronization rule. BGP synchronization ensures that BGP routers do not advertise a route to an external BGP neighbor until all routers within the same autonomous system have learned about that route via an interior gateway protocol or IGP or static route. In other words, BGP waits until the IGPs like OSPF or eIGRP has propagated the route information within the AS before advertising it externally. This is BGP synchronization is working, and this is disabled by default in our Cisco routers. We can if we enable this BGP synchronization, then BGP will not advertise route until it's learned about that route via IGPs or static route. Okay, let's see the difference between administrative distance between iBGP and eBGP. iBGP default administrative distance is 200 and eBGP's default administrative distance is 20. And this is why eBGP is superior to iBGP because it has lower administrative distance. And route advertisement behavior, iBGP routes received from P can be advertised to eBGPs but not to other iBGPs. This is the BGP Synchronization Rule. And routes received from P can be broadcast to both eBGP and iBGP. This is the good advertisement between iBGP and eBGP. There is no good advertisement between iBGP and another iBGP. And local preference attributes, iBGP sends as a part of BGP attribute, but eBGP does not. This is between local preference attributes. And next hop self behavior. iBGP, the next hop remains unchanged in iBGP, and in eBGP the next hop is changed to the local router. Okay, let me explain this one. Okay, there is eBGP contact between RTRB and transit. This is eBGP, and iBGP between A and C, and between AB and CB. Okay, transit routers will advertise. Let me say it has its local router is it has 1 1 1 1. This is next hop of this one. Then transit will advertise it to RTRB. It says my next hop is 111. This is my local number is 111. They will advertise to RTRB. Then RTRB will, because there is iBGP between RTRB and RTRA, then RTRB will not change its next hop. Then it will advertise the next hop of 1 1 1 1 to RTRA. Let's say RTRB's address is 2222. If transit router advertises its hop, its next hop to RTRB, the RTRB will not change this 111 to 222 and advertise it to RTRA. Instead, RTRB will advertise the next hop of transit to RTRA and RTRC. Then RTRC will see this will see 1111 for this route, and in our network it may cause route reachability issues because RTRA does not have any information about 1111 until we advertise this 1111 into our network. And to overcome this issue, we can use BGP Next Hop self on RTRB. If I configure BGP Next Hop self on RTRB, then RTRB will change this 111 to 2222 and advertise it to RTRA. Then RTRA will see 2222 the next hop of RTRB instead of next hop of transit. Give me one. This is next hop behavior in iBGP and eBGP. iBGP's next hop remains unchanged. And this behavior will cause reachability issues. Okay, let's see another BGP concept. This is BGP Route Reflector. So because iBGP require full mesh topology configuration, then we can, for easy configuration, we can use BGP Route Reflector and configuration. Okay, let's see BGP Route Reflector. iBGP rule or BGP Synchronization Rule. As I explained before, iBGP will not advertise a BGP advertisement length from one iBGP neighbor to another iBGP neighbor. This was Lupe mentioned, synchronization rule. And for this reason, a full iBGP should be maintained within the autonomous system. For reduce resolution to resolve this issue, we can configure BGP route reflector. The BGP router to be a route reflector. Okay, BGP Route Reflector. Okay, there are three types of route reflector peerings. Let me explain this three types of BGP route reflector peerings. This is okay. Before I explain, let me explain. This is in BGP route reflector we have something like cluster. We have cluster, then we have a client, then we have non-client. Let me show this. This is non-client. This is non-client, and this is our non-client, and this is our non-client. Let me draw another eBGP here. This is eBGP neighbor. This is eBGP. Let me draw another eBGP there. This is our eBGP neighbor. Okay, we have eBGP neighbor, we have route reflector, and we have client inside cluster and client outside cluster. The client outside cluster are called non-client. Okay, now let me explain this three types of BGP peerings. Okay, we have eBGP neighbor or neighbor to route reflector. This is our eBGP peering. Then we have iBGP client neighbor. This is iBGP client neighbor. These are neighbors between route reflector and client inside cluster. These are our iBGP client neighbor. And we have iBGP non-client neighbor. These are non-client neighbor. These are non-client neighbor between route reflector and client outside cluster. Between non-client and outside cluster. Okay, now let's see BGP route reflector rules. Okay, route learned from an eBGP neighbor can be forwarded to another eBGP neighbor, client and non-client. Okay, route learned from eBGP neighbor, if I route reflector learns from eBGP, that it can be forwarded to client. This is our client, and non-client. Route identifier eBGP can be forwarded to client inside cluster and client outside cluster, and another eBGP either. Another eBGP either. Okay, route from eBGP neighbor can be forwarded to all our neighbor. eBGP client inside cluster and client outside cluster. And route line from a client inside cluster can be forwarded to another eBGP neighbor, client and non-client. It's the same as eBGP. Okay, route from client can be forwarded to another eBGP, another client, and client outside cluster. It is working if I from client, same as route line from eBGP, and the difference is this one. And we can change this client to client reflection by no BGP client to client reflection command if we want to disable this behavior, client to client reflection. And third one is route line from non-client outside cluster can be forwarded to another BGP neighbor client but not another non-client. This is normal iBGP rule. Show this one. Yeah, this one. Okay, route line from non-client can be forwarded to another eBGP neighbor client, but not another non-client outside cluster. This is normal iBGP rule. Non-client, there is no client to no client advertisement in BGP Route Reflector. And for compare this route reflection, we can see this command only on our route reflector router. Neighbor IP address, route reflection clients. This command is only on route reflector, not on route reflector clients. For verification, we can show iBGP IP address, and there are two attributes. One is originator ID and cluster list. The originator ID is set by route reflector, and when an iBGP router receives a route with its own originator ID, it will not accept this route. It will drop that route. This is for loop prevention. And cluster list. Cluster is the router ID of the route reflector, and when a route reflector sees its own cluster ID, it will drop the route either. And keep in mind that if we see more than one cluster IDs in our network, then we have more than one route reflector. We can verify our route reflector in our network by cluster ID. If there is 3 cluster IDs in show IP BGP, then we have 3 route reflector on our network. Okay, now let's see the last concept, BGP Dynamic Neighbor and Peer Group. Okay, to configure BGP Peer Group, we can create a peer group by this command: neighbor, peer group name, and specify peer group. We first specify peer group name, and we specify peer group, and we specify peer group parameters by neighbor, peer group name, and specify parameters like remote AS, update source, and route reflector. Keep in mind for route reflector configuration in eBGP should be done on the address family. And to upload this peer group, we can use neighbor IP address peer group command. Okay, I will not explain the split append for this section. And we have BGP Dynamic Neighbors. We can conquer BGP neighbors in two ways. One is manually and the other one is dynamically. To conquer BGP dynamic neighbors, we first conquer BGP AS number, then specify our peer group name and its parameter, then type BGP listen range, then our network and length of our remote neighbor. This is the network and length of our remote neighbors, and special peer group and peer group name. This is so easy to conquer our BGP dynamic neighbor. Okay, that's it. This is a BGP concept for this section, and let's configure this section. Okay, let's start. Where is my... Okay, this is our section. We have to conquer BGP AS. This is... This is... This dot notation, BGP concept. This AS dot notation instead of AS plain. And the default is AS plain. Then we have to convert this AS plain to AS dot. Because this AS dot configuration. Convert between AS this number on 1, 2, 3, 5, 6, and 7. Let's show this network. Okay, this is our topology here. Let me show you. Okay, RT is our hub, and 2, 1, and 7 is our DMVPN spoke. I said client. So hub and this is our spoke. R6 is not our DMVPN spoke. I'm gonna show if I type DMVPN. This is hub. Show DMVPN. This 3 spoke 1, 2, and 7, and this is our tunnel address. But R6 is not our DMVPN spoke. We have to conquer BGP on 1, 2, 3, 5, 6, and 7. One, 2, 3, 1, 2, 3, 5. This is 5. We have to come on 5 and 6 and 7. The 6 and 5 are not in our DMVPN network. Okay, it says conquer RT as BGP Route Reflector for 1, 2, 6, and 7. One, 2, 6, and 7 should be RT should be with reflector. Let me try this one. This is RT with reflector, and the 1, 2, 6, and 7 should be client. 1, 2, 6, and 7 is our client. Okay, and RT should dynamically establish BGP peering with DMP spoke router and do not convert manual neighbor establishment on RT for any DMP spoke router. Okay, for this, because R6 is not in our DMP network, then we should configure neighborship between 6 and 3 by manual configuration, by neighbor command instead of dynamic neighbor. We have to create dynamic neighbor on RT4, 2, 1, and 7, and manual neighbor establishing between 6 and 3. Okay, let's go and cover this. Let's start by hub. Config T, hotel BGP, 65, 0.25. Okay, now if I do shutdown, pipe section, hotel BGP command here, you see I will see this value as AS plane instead of AS start. Then I have to convert this AS plane into AS start notation by BGP AS notation and dot command. Now if I do sharp now, I will see AS start notation instead of AS plane. Okay, now let's see do show IP interface brief. This is our tunnel. Let's configure BGP Dynamic Neighbor on RT. Let me configure Peer Group first. I have to configure Peer Group. Let's say neighbor. Let's say Peer Group name iBGP. Then this is my Peer Group name. Then remote AS neighbor, then iBGP and remote remote AS and local AS should be the same. Then I will use update source on our tunnel interface instead of our outgoing physical interface. Then type neighbor. Update source. So tunnel 100. And RT is our route reflector. These are route reflected, and then I have to come with the command. Keep in mind the neighbor, there is no okay, but let me disable this MPBGP first. I think no IP, no BGP default. If I disable this default, let me show if there is. If I now come on neighbor, there's a reflector client now. I can see with the reflector client at this moment because I haven't disabled it IP before unicast. Now if I disable no BGP default IPv4 unicast, then I have to activate. This is how it becomes MPBGP. In MPBGP conversion, I have to add this route reflector on the address family. If I type neighbor iBGP, I can see route reflector at this here on this section. I have to go on the address family. Address family IPv4 unicast. Then I can see route reflector here. Not here. Okay, now I have to use exit, and I have to BGP listen. BGP listen range, and this is a tunnel. .co, and length is 24, and specify my Peer Group and Peer Group name. Advertise my Peer Group name, iBGP. Okay, now on the address family IPv4 unicast, I have to activate neighbor, the neighbor IP group, and activate. Okay, now let's configure our clients. Okay, do show the pipe section with the BGP. This is my BGP configuration. There is no BGP listen range. And this is our router R1. There is no peer group either. We don't have any peer group. Default, this is the same. Okay, then we have to spawn neighbor and activate it. Okay, let's go this one here. Config T. On top neighbor. A neighbor should be my hub IP address. User IP interface. This update source is from this one. And the route AS is this one. Local and route AS should be the same. And on the address family, IPv4 unicast and neighbor this one activate. Summary, and my neighbor is up. Redistribution down pipe section with a BGP. This is my BGP configuration. We are client. Okay, this is the same on other clients either. So let's go to the other. The other client is R2. If I go to R2, config T, this one. Up. Then last one is R7. Config T. This one. Okay, now let's configure neighbor between 6 and 3 because 6 is not in the MVPN network. Then I have to configure this manually. I will use loopback as update source. Okay, now let's go on R3, R6, R3. I have to add this neighbor to 6666. unactivate. Then I have to use update source, look back. And because at his client or at his route reflector, I have to use neighbor. This because it is MBGP, I can come go with reflector client here. Then I have to go on the address family. Then I have address family, IPv4 unicast. I type net. And here I should type neighbor route reflector client. We have to first activate this neighbor. Activate and type neighbor route reflector client. Then on R6, I have to configure my BGP. This is the same as this one. Instead, I should use TTT2. It is my limit AS. And I have to add update source either. Show down pub section. And neighbor 3333 activate. Okay, this is configuration of what on R6 I use BGP number, no unicast. This remote AS is this one. This is IHOP. Update source loopback, and on the address family, I activate my neighbor. Six. Okay, now this is done. This is done either. I'm gonna reflect on a 3 client on this one, and I should dynamically establish peering with my neighbor. This is done either. Then there is manual neighbor configuration between 3 and 6, and then we have come new loopbacks on 1, 2, 3, 5, 6, and 7, and loopback number is 99 with IP address of this one, where X is a router number. Then advertise this new loopback to BGP at each device. Okay, let's do this one. Okay, let's create loopback 1, 2, 3, 5, 6, and 7 on our devices. Okay, loopback number until 1, 2, 1, 2, 3, 5, 6, and 7. Let's close this one. And 150. 150. Interface loopback 99. Then IP address should be 110.99. 10.99 and for 1 it should be 32-bit. Okay, IP address 99 and 2, and this one, oops, IP address 99 and 3, IP address 99 and 5, and IP address and 6. And IP address on 1997. Then I have to advertise this group back into my BGP to loop into at each device. Okay, I will advertise like with map. I will create with map first, and with map connected to BGP. Then match my loopback. Loopback 99. Exit. We show down. +7 6 2 and 1. Now let's open our server. Okay, now on the route BGP, we show down our section route BGP. I have to redistribute. And config T. Okay. Now go to route BGP. Then on the address family, then top redistribute. Connected route map. All of this one is correct and type. Okay, this is this one, and let's see another. We use this one and copy BGS this so that following output is matched on R6. So let's see, this is following, the following output is matched on R6. Okay, this is show BGP IPv4. This is MBGP command. Show up instead of IPBGP. It uses show BGP instead of IPBGP. This is MBGP command. On our R6, we can see that this is 555 and RT. And from this cluster list, there are two route reflector here. We have two route reflector. One is 7 and the other one is 3. And then our neighbor is 3 from our 6. Okay, I have to come with BGP on R5, and this and R5 is from this output shows that R5 should be client of R7. It's because there is two route reflector in our network. Then This R5 should be my another route reflector. Then 7, then R7 is our route reflector. Then R5 should be my route reflector client. From here, if I do show BGP with a loopback as R5, then there should be 2 route reflector and the neighbor is 3. Okay, let's configure BGP on R5 either. On R5, let's configure here. To show pop section with a BGP. Change this BGP AS notation dot command. Then no BGP default. Okay, now R5 should be client of route reflector client of R7. Let's see BGP configuration here. Let's see to show pipe section BGP. And then this okay, R7 is client route reflector client. R7 is route reflector client of R3, then R5 should be route reflector client of R7. Okay, now let's configure route reflector command to check on neighbor 555.555.5. The route AS is the same as this one. Then update source should be loopback 0. Update source loopback 0. And because R7 is route reflector of R5, then I have to configure this command. Neighbor, I have to go on the address family. Address family IPv4 unicast. First activate my neighbor 555 activate, and neighbor 555 route reflector client. Okay, now let's go on file. Let's finish this configuration either from here. I'll go to here, go to this one, then I have to type neighbor 777. Remote AS is the same as local AS. Then update source should be loopback 0. Update source loopback 0. Then I'll go address 1 milli IPv4 unicast. Then I will activate my neighbor. That's it. Okay, now up now. And now let's verify this command. Show BGP IPv4 unicast, and this is the loopback of us 5. Do show IP BGP, do show IP interface brief, do show IP. Brief. This is the loopback of our 5, and verify this here. Show BGP IPv4 unicast, and this one. Okay, now this is BGP one path available. Local is, this is 555. eBGP meeting is 20. And this is FIAM 3. Metic, and our cluster list. There are two cluster lists. One is 3333 and 777, because there are two with reflecting in our network. And our originator is this one, ID, cluster ID. And if I am here, we can, our 6 is only has neighbor connected with 3. Show IP BGP summary. There is no contact between 7, because there are 2 route reflectors in our network, and this is comes from the second route reflector. Okay, that's it. This is how we can configure BGP in our network. I hope you have enjoyed this video, and thank you for viewing.